Dzień dobry. So, hello. It's nice to be here again. Last year I've been on the same stage for the first time. So thank you very much for Jakub Svolek for inviting Cloudera and myself to present again this year. Last year I had more hair. I wouldn't say a lot, but a bit more than this year. And I've been presenting on a different topic that I'm covering today. So last year I was focusing on how to democratize data science, so how to make data science a self-service experience on top of a data platform like Cloudera. But that was really last year. So things have changed. As you've seen in the Atos presentation, which I think was an excellent coverage of the topic, data science and data lakes, so basically applied data science, for example, in the field of cybersecurity, is very much connected to data platforms. You cannot do meaningful analytics, you cannot do meaningful cybersecurity defense without having access to huge amounts of data. So this is something that we know now for a while. This year, I would like to focus more on the user, so focus more on those people who are analysts, who are big data engineers or administrators, and who are interested in building data lakes for analytics. So I'm going to talk about a cloud data warehouse, but before I jump into this, a short round of a poll maybe. How many of you have a data lake, or how many of you work with a data lake? So data lake can be anything, yeah? It doesn't have to be a Hadoop cluster. So again, hands up please, I don't see much. Okay. How many of you have this in the cloud? So not many, okay. I wondered, there are of course some reasons for this. I'm going to show you one approach of building a data lake, or actually to be more sophisticated, a cloud data warehouse using some of the ingredients that are available today. So what do you need to have a data lake? You pick a cloud. It could be Amazon, it could be Microsoft Azure, depends on what your organization prefers. What you also need in addition is you may want to choose an open ecosystem. Usually a data warehouse is a playground of big legacy vendors, which are mostly closed systems. But thanks to the wave of big data and the largely available open ecosystem around it, it's now possible to store your own data in a cloud and bring the data warehouse to your data. So I'm going to show you some architectural patterns, so you don't need to make all the considerations yourself when you're building one such solution. And again, it's good to have someone who is backing you. So if you work with critical data, you may want to have a trusted vendor who has been around for a few years and who knows what, someone you can rely on. And of course, this platform is best self-service, so it means you, analysts or business users, can do as much as you can without the need for IT, without waiting for IT. And there is some more which I'm going to present you. Some other special ingredients which are missing out from most cloud data warehouses. So, let's get started. So what are the motivations for moving to the cloud? I assume you've seen some of these numbers before. These should not be completely new to you. Because the biggest advantage of cloud is not cost. So those of you who have been working with cloud, with public clouds, who have been running more workloads or storing your data persistently in object stores, you've probably seen that cloud is not necessarily cheap. The most important advantage of having a cloud platform, or storing your data in a cloud platform, or running your workloads there, is scalability. So it means if your business or if your organization has yearly trends or daily trends, you don't need to scale your on-premise system to meet the peak demand. You can use a cloud platform to scale it elastically. Elastically means, you probably know the word, when you have more load, you add more resources, and when you have less load, you remove resources. It also has flexibility. So why you may need to decide for an architecture in the cloud as well, and you may have to think about operations in the cloud as well, it's much more flexible to add new components or to change the components. If you think about on-premise, you need to order hardware, you need to buy software. It's usually a cycle of 3 to 6 months. In the cloud, you can provision new resources and buy new services in a couple of minutes. And this is the same in the third part. When you have flexibility, you can much faster respond to the needs of business in terms of new compute resources, new data storage, and introducing new software. And if you are smart enough to leverage the elastic nature of the cloud, overall, you will be able to drive costs down significantly. So these are the results of a survey that was published by TTWI 2 years ago. And these are some of the motivations for moving generally towards public clouds. So some of the stakeholders who are interested in a cloud shift are behind me. The first are the analysts, the business users, who want to work with data, who want to run their applications, who want to focus not on infrastructure but running jobs. A job could be anything. It could be a Spark job where you want to do some ETL. It could be a heavy lifting data science job where you want to do some transformation that needs more compute resource than your notebook, than your laptop. You want to run it on more resources. Or you want to have a cluster, some BI platform, where you can do, in office hours, do some meaningful SQL analytics. So basically you want to have an ad hoc data mart that runs only when it's needed. So this is what business users want. If you look at the data teams and look at the infrastructure teams, it's also beneficial for them, but I don't want to spend time focusing on this. Maybe I'll just move on and give you some of the common patterns of analytics in the cloud. So the most important pattern is that if you think about big data, you probably know that the revolution that big data brought to IT is having data and computation at the same place, on the same machines. So you don't store data in some network storage and move it to some compute engines, losing time, limited by bandwidth, but you do this on the same cluster. In the cloud, again, this is however changing. It's actually moving backwards. The main pattern is that you store data on some object store. You probably know S3 storage, you probably know Azure Data Lake storage. These are traditionally object stores for storing basically any data, but with a cloud data warehouse, they become the primary storage for structured data as well. So this is where you store your CSV files. This is where you store your Parquet files. Any data that you need, and then you bring your workloads on the same cloud platform. But you can scale the two separately. So you store persistent data in an object store, and then you can spin up compute to run some of the workloads that you see here. So ETL. One department can run one of his ETL pipelines in one job, maybe in one cluster that's only provisioned during the execution time of the job. Another department can run another ETL job on another cluster with the same data, and they no longer interfere. If they have different budgets, if they have different SLAs for their jobs, it's easy to maintain them while access to the data is the same. And the same goes not just for data engineering, but also for BI. So think about large enterprise that has a risk department, a marketing department, has a security department, as we saw previously. They may want to have access to the same underlying data. And IT doesn't really want to set up privileges each and every time for every different use. IT, and this is I'm going to cover in some later slides, you only load the data once. You only set up permissions once, and then when you add new workloads, these different users can scale, can buy, can choose their own resources, while accessing the same data. So not creating data silos, which need to be integrated by IT, but accessing one unified data layer. So this, of course, also has benefits. So this means you only pay for data that's persistent, and compute is only required when you're actually doing some meaningful calculation. When it comes about an ETL job, a data transformation job, You only need a compute resource when your job is running. If you talk about self-service BI, you only need to pay for infrastructure when you want to do analytics. It could be just 40 hours a week compared to 168 hours, which you would pay for on-premise. And the big trap, however, so this is something you can do with any cloud provider. You find lots of options for this available, not just today, but in the last years. The biggest risk is, however, when you do this, you may be actually building data silos. You may be setting up disparate databases that have no real connection. So how can you avoid this? I'm going to give you an answer in a few minutes, but let's just finalize the technology that lies under this cloud approach. So you take one cost-effective, persistent, secure data store. Then you put on top of this a scalable and elastic usage-based compute, which you only need to run when you need it. And on the top layer, you choose some open platform. You choose some open architecture which allows you to store your data in a format that is open and that can be reused, that is optimized for analytics. Or not just the storage formats, the engines which you are using, may it be Impala, the BI, the MPP SQL engine preferred by Cloudera, or let's say developed and open sourced by Cloudera, or Spark, where Cloudera is one of the major contributors and users of Apache Spark. These are open source engine. This means you choose this, you choose an open data storage, you choose scalable compute, you choose an open data architecture, and you are free to put any data application on top. So finishing up, what you're getting as a benefit are a couple of things summarized here. You get really performant SQL access because you can scale your resources as needed. There is self-service flexibility. It can be cost effective, and you have in the end an open architecture where you are free to choose the tools that you're running on top. So moving on, about some of the options that you have when you think about building such data warehouse. On the left side, if you think, historically, you used to have monolithic data warehouses or data marts. You had one system for serving SQL queries, which was also storing data in some proprietary format. And then a couple of years ago, data lake concept was introduced. And in the data lake, you have shared data on some on-premise storage. Let's call it a big data cluster, a Hadoop cluster. And then you run multiple different workloads. And the workloads could be BI workloads, could be ETL, could be data science workloads, or even on the same data you can run real-time applications. You can ingest not just batch data, but real-time data and so on. I'm sure you're all aware of this. So this was the main pattern in the past. And as I mentioned, in the cloud, the concept is similar. However, data is shared, and the workloads no longer run in one big cluster, but actually they run in separate clusters. Today they run in clusters. Next year they will no longer run in clusters. They will actually run on some elastic compute. The vision is, and it's not just Cloudera, if you look at the news, everybody is trying to run Spark on Kubernetes or to run BI on Kubernetes, that you are no longer bound to buying or spinning up a large compute infrastructure. Actually, all the jobs eventually will become elastic. So if you think about the options, there are three main options that you can do, speaking of data warehousing. And now in terms of data warehousing, I'm focusing more on actually running BI queries. And the typical option right now, as we see in the market, is that even though the cloud offers elasticity, most of our customers, they prefer to have a long-running infrastructure, a long-running cluster in the cloud. So what this means is that the compute layer is very similar. They have a more or less static cluster. More or less static means there are a number of nodes which they can change, grow, or shrink as required. But it's still something that mainly runs 24/7. We call it a persistent cluster. Underneath, however, the data is already stored outside of the cluster, it's stored on S3 or ADLs. And thanks for the engineering efforts coming from these cloud providers, together with Cloudera, the performance between an object store-based data and the local block storage attached data is actually very comparable, which means you no longer need to isolate your data in your cluster. You can store it on these object stores, and then you can access it also from other services or from other workloads. So this is, let's say, the most typical pattern. The benefits is that basically you have your own dedicated infrastructure. However, compared to on-premise, you can scale it. You can add and remove resources. And yeah, the most important benefit probably that this gives you a predictable performance. If you think about something that should give you even more performance is mimicking the same strategy that you have on-premise. We call this lift and shift. If a company would want to copy what they have already on-premise, but try to leverage OpEx instead of CapEx, so the main reason is basically to leverage the cloud without changing much of the infrastructure, they do lift and shift. And then you have a persistent BI solution where you are using most of your data inside HDFS or Kudu, which is also an option in a CDH, a Cloudera cluster. You pay for it licenses on a node basis, and of course some of the external data you can store on an object store. The benefit is this: you can get even better performance if you store data in the local scale-out storage. And let's say you have static costs in this way, but generally costs will be for sure higher than in the first option. And then there is a tendency that we see more and more growing, and this is something that's fully transient. So imagine an agile company which doesn't really want to spend much on infrastructure, may it be on-prem or cloud infrastructure. They say we want to pay only for what we actually use. And this is exactly the case when you have, let's say, by default, zero compute, or just compute where you really have something running every day, every hour. And when your analysts come to work in the office, 9 a.m., and they go home 5 p.m., you only need to give them the compute infrastructure for these 8 hours. And this is exactly what's also available through the third main pattern, which is having fully transient workloads for BI. And this is something I'm going to spend a little bit more time on. And I'm going to introduce you, call it Altus, Cloudera Altus Data Warehouse. So I'm not going to make it very marketingy. Just want to explain that Cloudera, who is one of the main vendors, or actually was the main vendor to come up with a Hadoop distribution back in 2008. We last year decided to become more cloud native, and the Altus brand summarizes all our offerings, all our attempts to bring big data into the cloud and make what you are used to in terms of big data more cloud native. And with the Altus Data Warehouse, it is possible to run BI workloads and ETL workloads, and soon also to do self-service on-demand data science on Python or R, also in the cloud in an on-demand manner, using the same set of data. So if you look on the picture on the right, I hope it's visible. The meaning is, or the concept is that you store your data in your S3 buckets or your ADLS folders. You set up, with the help of data governance and IT, an integrated layer of security, meaning authentication, integrated with your Active Directory in the cloud, authorization, using Apache Sentry, which sets permissions for Active Directory users or user groups on a folder level for every file, and also on a database level, a table level, or a column level for your databases. And this is then enforced through your object store. Actually, not the object store. This is what we call SDX, a shared data experience. You provision an additional persistent layer which stores the metadata information, it stores the security, as I mentioned, it stores the schema information of your files. So if your files, they have a structure, all this Hive MetaStore information, this schema information is stored in a database that is persistent. Then we have audit integration with Cloudera Navigator, which is our audit and security component, which means even if you run something only in a transient way, the audit logs, the event logs are gathered from this job, and they are captured and stored on a persistent cluster, so auditors can also see all the actions that were performed by transient jobs. So you have this shared layer of security and governance, and then you can add workloads on top as needed on demand. Okay, I'm just going to sum up here what I've said so far. We have a couple of options in the cloud. As I mentioned, you can do data engineering, run ETL jobs. You can do data warehousing, spin up BI clusters, use Altus SDX, the shared data experience, to set up schema, security, and governance only once, and leverage this every time you add new workloads. And if this is not enough, you can use Cloudera Altus Director, which has been around for several years, to spin up arbitrary clusters in the cloud that can run any workload that you can run in a cluster. So if you think about running an operational database, operational data store, a real-time application, you have the option to spin up a full-blown cluster next to the platform as a service offerings and leverage this shared data experience to interact with the same shared data. Okay, so just to summarize how this looks like for technical people, you have your data in buckets. You add this persistent layer of metadata, security, governance, data engineering, so ingest, replication, data integration, and workload management, which is I'm going to talk about in my final slides. And then you bring your workloads, you bring your on-demand compute. And this is something that business users can bring themselves. IT does not need to provision these resources. This is something that every business unit can do for himself. So just to summarize, if you think about what you're using today in the cloud, I know you're not using much, so probably this slide is not so relevant for you. But these are some of the most important topics why we believe that our solution, or this solution, is a good approach to cloud data warehouse. And I'm really hoping to see from the industry similar solutions in the future. So this summarizes what we've been doing so far. So this is the architecture of our traditional on-premise solution. If you see on the bottom, this has been extended to cloud. So if you run your cluster on-premise in your data center, you can integrate cloud resources. If you have data in buckets, you can integrate this using Cloudera Manager in the same cluster that you have, and then you can combine in your queries, in your data processing, data on-premise or data in the cloud. This has always been possible, but now we are shifting this and we are extending this towards the cloud, making it cloud native, so allowing not the data in the cloud to be brought on-premise, but actually the computations, the workloads, move to the cloud, creating a hybrid solution where security, governance, and metadata management, metadata information is unified. So you don't need to start from scratch. This is the way we are actually helping our customers in the region. So I work in Central Eastern Europe. I come from Hungary, Budapest. But I work with customers in Czech Republic. I work with customers in Poland, in Slovakia, and the rest of the region. And they are looking for this solution. They want to go to the cloud, but they know that cloud is risky. And they are looking for a trusted vendor who can help them to leverage all the benefits without risking their career in the company by making a big mistake. So this is exactly how we are helping them. If you want to do a free ride, although this is an enterprise solution, you can do a free ride anytime. Just go to cloudera.com/altus. You can register and immediately get a free access. You only need to bring your own cloud, so you need to bring your own Amazon account or your Azure account. Make sure you have data already, and then you're actually bringing the power of this Cloudera platform to your data. So when you're using Altus, you are not moving data around. You are not moving data out of your buckets, out of your folders. You are really bringing clusters, compute, to your virtual private networks, not networks, your VPCs, your virtual private clouds, and this is where you do computation in your own existing data. So the data stays yours. So this is what I wanted to say, and I was hoping that I will still have some time. So if you have 5 more minutes, I'm going to show you one more topic that we've been working on. And this is exactly what we call, before that, the motivation. Let's say you did exactly how I said, and you managed to set up a cloud data warehouse. But then comes the second question, which is, how do you keep this running? You have set this up, and now users are coming in. And the biggest problem with IT systems is users, of course, because users will start using it, and they will ruin the experience, right? They will bring their workloads, they will bring their queries, and then it will be a problem to keep the infrastructure up, to keep the resources managed, and so on. So this is where we have a new solution, which we have announced in the beginning of September. It's called Workload Experience Manager. And I brought you a short video, which can summarize much better than I can do. So maybe I will ask to start the video now, and hopefully you will be able to see it.
Leading modern platforms like Cloudera run business-critical applications and workloads that are hosted across multiple tenants and enable customers to make data-driven decisions. Since these customers cannot have application failures or unplanned downtimes, it becomes extremely important to proactively monitor and optimize the performance of their workloads. A key challenge faced especially by solution architects is the inability to proactively monitor, analyze, and manage big data applications and their resulting workloads through a single tool. In this video, I will show you how Cloudera's Workload XM can help you address this challenge. Let us take a look at the metadata of a sample customer, who is a typical mid-sized financial services organization. They have over 7.5 million files or directories, 196 terabytes of non-replicated data, with most of their user data being generated as small files, 223 databases, nearly 7,000 tables, and running approximately 2 million queries in just 4 weeks. For Bruce, who is the senior solutions architect at this customer, just monitoring the performance of the applications and workloads across this landscape is a challenge. A few questions that come to mind are: does Bruce meet all of his SLAs? Do his users complain about waiting too long for their jobs to start? Does his system perform consistently? How can Bruce avoid application failures? Does he have an efficient way of performing root cause analysis? The key to answering these questions and optimizing his data warehouse is to get a better understanding of his workloads. Let me show you how Workload XM can help Bruce achieve that. For this demo, let us focus on just 2 weeks of workload metrics and use Workload XM to get a deeper understanding of the health and performance of his workloads. First off, nearly 2% of the 20,000 odd jobs are slow, which means that Bruce is at a high risk that his SLAs will fail. Here you can see all the jobs that are run by our sample customer during this 2-week period and are in poor health. Say Bruce has an SLA from his customers that no job should run longer than 10 hours. Let us use Workload XM to firstly find out if he has any jobs that fail our health checks. Here you can see there are quite a few jobs that have not only failed our health checks, but also do not meet his customers' SLAs. Let's dive deeper into a Hive insert override query that runs for over 11 hours and see if we can find anything that can help Bruce. Here you can see that 4 tasks have a heavy skew in their task duration, and 2 out of the 643 tasks take well over 10 hours. Going deeper, he can see that not only is there a failed attempt, but it is also processing way more data than the average task. If this problem didn't exist, the reduced stage would have finished in just 13 minutes and 16 seconds, similar to his other tasks. In the meanwhile, Selena, one of the application developers, has been facing a different problem. Every now and then, she fires a query, waits for a really long time, and it simply fails. Can Workload XM help? Let us find out. Firstly, let us find if she has any jobs that have failed to finish. Now that we see a few jobs that did not finish, let us take a closer look at one of her queries which ran for more than 13 hours and still failed. By simply clicking on this query, she can see that the failure has occurred in the reduce stage. The execution details section will give her more information. And by clicking on the failed task, she discovers that the reason for the failure is a high runtime error. By opening the associated log file, Selena can further analyze the root cause of this failure. Now Bruce has another issue. Application developers and other users across his organization have been complaining that their queries seem to take forever to start, or if they start, then they take forever to finish. Let us go back to Workload XM to get to the bottom of this. Let us look at one of the jobs run by the credit risk group to ingest information for credit reports. At first, Bruce finds that this job took 19 hours and 40 minutes to complete. When he dives deeper into this job to look at what is happening at a task level, he discovers that this particular task simply waited for 19 hours and 15 minutes, and once it started, it took only 24 seconds to complete successfully. This could mean that the credit risk group may be short on resources, and Bruce may not have allocated sufficient resources towards this group. In a different group, Barbara, who frequently uses the system to generate BI reports, she files her queries to find that they're suddenly taking longer than expected. With Workload XM, Barbara can find out what exactly is going on. Let us first filter some of the queries that have been run by her. This particular execution of the operation called Account Analytics seems to be taking close to 2 hours. Let us go deeper and find out what's happening. There definitely seems to be a spike in the time taken for this particular run. We can verify Barbara's claims about the previous runs by looking at the trends. Here you can see that the job that typically takes an average of 32 minutes suddenly took 3 times longer to complete, despite of the fact that it has processed and generated the same amount of data as her previous runs. Let us look at the execution details to try and understand what happened. You can see that the map stage did not start for more than an hour since it was launched. This could mean that there is a resource starvation issue or an issue with poor parallelization. In summary, we can see the impact of Workload XM on various workloads in Cloudera's versatile data platform and how it delivers tremendous value through its features, including comprehensive risk assessment, self-service analytics, and quick time to value.
So thank you for watching. Just to conclude, think about this. You have your data, you bring your data warehouse on your data, and I promised that my presentation is about getting a self-service experience. So you can set it up, you can set up your workloads, you can run your workloads, you can do meaningful analytics on your own data. But if you run into issues, who will help you to troubleshoot them? Who will help you to optimize? And this is what you see in the video. The Workload Experience Manager is actually part of our cloud data warehouse. So if you go today to the Cloudera.com Altus site, if you register, if you start running your Spark jobs, your Hive jobs, your PySpark jobs on your data, they will be tracked by the data engineering part of Workload Experience Manager. And they will tell you, hey, by the way, this is the reason why your job is running slow. Or imagine you're running the same ETL job each and every time, every night. It's common with most organizations. You do some data processing in the night that your systems that open in the day are using. Everybody in this room, I'm sure, has experienced a situation when your job was running longer and your system could not open on time. And then you do troubleshooting. You want to find out what's the issue. Is it getting worse? What's going to happen tomorrow and after tomorrow? And then you need to log into log files. You need to contact the vendor for support. With this tool, which is part of our cloud offering, you get meaningful explanation of what was wrong, and you can take actions without browsing through thousands of lines of log files. And there is more to this. We have a component that can help you migrate your existing workloads from legacy data warehouses, which will help you analyze your current queries, current patterns, and explain to you how much of these workloads, how much of your database schema can be easily moved to a big data platform. There is a component which helps you get a big picture of what's going on in the cluster. This is more for the administrators, but this explains where are bottlenecks, which are the usage patterns, how is the usage of the cluster changing over time. We are working on a component which is in beta that helps you optimize your workloads. So if you have a job that needs to finish in 2 hours and the data volumes are growing and it's starting to go out of these 2 hours, what can you do? How can you grow the resources or buy a stronger cloud instance to make sure that you stay in the 2-hour SLA? And finally, as you saw here in some of in the video, you can troubleshoot each of the jobs, maybe a Hive job, a Spark job, or an Impala job, and see where are the problems that is causing bottlenecks. So overall, this is a summary. These are some of the highlights that you're getting with Workload Experience Manager. And with this, what we are trying to achieve is this. How do I share potentially petabytes of verified data across thousands of users who have a limited or different skill sets while you are maintaining costs and SLAs for your organization? So this is where Cloudera Altus is helping you. So I hope you are beginning or already on a journey to leverage benefits of the cloud for data warehousing. Feel free to reach out to me if you are looking for support in your journey. Thank you very much.